write a program that displays or demonstrates the GUI graphical library for writing UI programs. So it's important that you can see whatever is happening on this in this terminal. So if the text is not clear, then please shout so I can make it bigger. Otherwise, I'd like to use as much space as I can to contain as much of the program as possible. So GUI is a UI library written in Go. And what's special about GUI, other than being written in Go, which is rare enough in itself, it's also using a particular programming design or paradigm, which is usually called immediate mode. And in immediate mode, contrary to other toolkits, you don't have any state hidden inside your toolkit. So if you've ever written an Android app or an iPhone app or just something with Qt or similar, you're probably used to having to describe your user interface as a series of widgets and containers and all that, but you have to give that description somehow to your UI toolkit. So if you've written Android applications, you typically have an XML file describing your user interface. You can also do it programmatically, which is where you construct your widgets and containers and lists and so on, but you also always have to give it over somewhere. And the same applies to, of course, to iPhone development and also to many web development frameworks, because in the case of the web, the browser has the DOM, and the DOM is your user interface state, so to speak, if you consider your web page a web app. So in immediate mode, on the other hand, you never have any state in your program. You have state in the program, you never have state in the library, which means that you have to keep track of all the UI state and the structure of your user interface, but you are flexible. You have the flexibility to do that, to arrange your program as you wish. So let's try to create a GUI program. Let's start with the very, very simple UI Go. It is just package main, func main, as you are used to. And very, very quickly, we need a new window. And you also need a way to process the events that comes from that into that window, which means either point events or key events or something else. And you do that with a channel, which is connected to the window. And you can run through that by just saying, let's range through the events coming from the window. And as a special little quirk, in particular on macOS and similar operating systems, the operating system wants your main thread, which is, it's an implementation details, but it leaks through in the sense that you have to give up your main Go routine. And the way you do that is to run your program in some other Go routine. There. And then give up your Go routine, the main Go routine, just by calling this function. Right. So if everything went correctly, you can simply go run this program. It's called events. So this is just a blank window. Takes up the entire screen because it has a very low resolution at the moment. So this is just a blank window, but in this instance, the difference between other toolkits that you might be used to and the immediate mode way to do it is that you are in control at all times. So even though you have to give up the main Go routine, in this case, you are the one creating the window, which is normal enough, but you're also the one that extracts the events from this window. And that is important if you have other things that happens while your user interface is displayed. Let's say you have a request to the internet, you have an RPC request, or you're doing a database query. Anything that happens asynchronously to your program, you can then describe, and you can then run in a Go routine, and then have that selected, the events from those Go routines, from those requests, selected with a Go select statement, along with the events coming from the window. So this is very easy to integrate with whatever else you want your programs to do. So in immediate mode, the most important event or part of your program is the one that describes what goes into your window. And in GUI, that is called the frame event. And we'll say, okay, we have the event here. And if this event is indeed a frame event, then we are asked by the system to draw something. And the drawing we're going to do is being returned or handed over to this event, this frame events.frame. And in this case, we're just going to give it nothing, just to give the program some structure. Again, a blank window. And in this nil is hidden an operations buffer. And this operations buffer is fundamental to GUI in the sense that this will contain all your drawings, all your input handlers, and so on declared in one large buffer, which is then passed to this event.frame, and then you can forget about it. So there's no state hidden or saved from frame to frame. And let's see how that looks like. In our case, we're going to have this operations buffer. It's just an ops, which is simply encapsulating this list operations. And it's give it the ops. And a very simple operation is setting the color. And another simple operation is drawing a rectangle. We're keeping it simple just to see how we build up an user interface from the bottom up. So a very simple operation is just a paint op, which takes the rectangle where you're going to draw in. And in our case, let's just have a rectangle that starts in 0.0, the upper left coordinate, and ends in, say, the screen resolution is low. Let's just say 200 times perhaps 150. And finally, that operation is just a structure. This is a structure definition in Go, so you had to add it to your operations. It looks a little bit peculiar, but the thing is you define your operation and you add it to this operations buffer down here. And finally, of course, the entire buffer of operations are passed to frame so that this is drawn on the window. Let's try to run it, and you see it's a black rectangle. Not very exciting yet, but we're getting there. So another operation could be setting the color. Let's just quickly see that one, just to give a feel of what operations look like. Let's just set the color to red. If I can do this. So this again, you create a color operation that sets the current color, and then you paint with that current color. Red rectangle. So we're still very, very low level, but this is the essence of a user interface. You have a window or some surface that you draw on, which are your widgets, such as buttons and toggles and sliders and all that. But at the lowest level, this is operations that simply say what will they look like. And the other part of a user interface is input. And this is where the immediate mode design or the immediate mode way of structuring your program is radically different from perhaps other toolkits that you have been using. So just to demonstrate how you do it is, the concept is that you have something that describes your input handler. Let's say you have a widget, which is our red rectangle, and you want to handle key events for that. You're about to write an editor or a text field or something like that. You just want key events, which is when you press J, you want a J, and you press enter, you want to enter, and so on. And you have to have something that describes this particular widget. And in GUI, it just has to be something unique. And something unique could be a global variable key handler, which is just a pointer to an integer. And this integer is just your state, your button state. In this case, we don't have any state, so an integer is as good as anything. And then there is an operation to say, I'd like this key handler to be declared in this frame, to declare to be receiving input events. And you do it like this. So this is an operation just as coloring and painting, but this is an operation to say, this is an input handler. For pointer events, for mouse and so on, it's a little bit more complicated. You have to tell it which area you want to receive pointer events. So for our example, a key handler is more simple. I misspelled. Okay, hey handler. Right, so we go. And if the window weren't taking up the entire space, we should be able to see, not yet, key handler, key input hub. Just give me a second. It should be working. Of course, it doesn't work. I'm not sure why it doesn't work. This is the idea. You register your input handler as a pointer or something unique, and you can then handle events by saying, take the input queue from the window. Window has an input queue, and you can take the events available for this key handler. And this is, of course, why it doesn't work. I haven't done anything with the events yet. Sorry about that. So this operation just registers your key handler, of course. And this next line takes all the available events during the previous frame to this frame you're about to display, and gives them to you for you to handle. So in this case, we're ranging through all the events available, and we'll just print them out like this. So now when I press something, we get events on the screen. And this seems pretty simple and something that you can do with any toolkit. But the most striking difference is that this for loop, or whatever you intend to do with these events, are controlled by you. You don't have a callback that is ready to say set key callback to this function, which is then called at some point in time that you can't control. So this is, you register it when you want, at some point which is convenient to your program, and then you use the events call to give you those events for you to handle. And of course, you have to do a lot of things with these events. If you have a text editor, you have to implement all the things that you do with the inputs. And that is why you, of course, need something more higher level than these operations. So these operations are only to show you what is the basis of GUI, what is the basis of writing something in immediate mode style. So all that I'm going to show you from now on is built upon these operations, which end up in this frame. So very simply, let's draw something text on the screen, which is very normal thing to do. And first and foremost, we need something to draw it with. And something to draw it with in this case is a true type font. And there's a package in GUI which contains the Go font. Anyone knows the Go font? Created just specifically for Go. And it's very convenient because it's available as a Go package with the true type data contained in a byte array. So that's why that's the one that is available. But you couldn't, in theory, add all these kind of packages, one for each typeface. And the next thing you need is something to actually draw this label. And to make it very, very easy, there's a theme that I call material theme that is supposed to implement the material design, Google's material design, and that, among other things, contain widgets for drawing labels in all the standard sizes. And the next thing you need, which I'm going to get back to in a minute, is a graphical context, because there are no global variables in GUI. The next best thing is a variable that you give to every function. So, well, that's the graphical context. And the graphical context only needs that input queue that you saw earlier, which is the window queue. And that's all it needs from the window, really. So with that in place, and you have to initialize the context by resetting it to say, okay, what is the configuration right now for this frame event? What is the display resolution? What is the dots per inch and so on? all the widgets wants to know that so it can render at the same size and on different screens. So on this screen, it's very low resolution. You want the label to take up a certain amount of space. And if you have your phone, you have a very, very high resolution, and you want that label to take relatively the same amount of space. So all those information is contained in the configuration. And another thing, it also needs to know the size of the window. That's it for the context. And then you can say, theme, I like a header 1, which is a standard size in the material design, and say, okay, hello, GoLab. And this initializes a widget which contains this text, which is ready to be laid out. And layout simply is, by convention, called a method called layout, which simply takes a context. And instead of our operations, we are going to use the one built in as a convenience in the context. And this should be about it. Let's try to run it. Hello, GoLab. So as you can see, it's still the same operations underneath, but in this case, we have wrapped up the drawing and the setting up of the font and so on in one single theme, in one single widget, which is initialized by this call. And of course, you can say body 1 if you want a different size and so on. So the next thing you'd like is more than one label. So let's try and draw that. I say, okay, we have hello GoLab 1. We'd like to have number 2. And we'd also like to have number 3. And what happens if I do this? What are you saying? They will, I hope, overlap. So the first one of them are actually line breaking because it's too long for the display. But they will overlap, as you say, because there's nothing that prevents them to just draw wherever they want. So the act of moving things relative to each other is layout. And there are many different ways to do it, but in the case of an immediate mode, you simply do it as you draw. And there are various helper methods. You can do it yourself. You can add an operation that simply moves whatever is drawn a certain amount, but you'd probably like to describe your widgets and your positions in terms of each other. So for example, let's say you want this, let's do it a little bit smaller, H3. You'd like this to go in the middle of whatever container you're in. In this case, it's the entire window. And for that, there is the layout package contained all kinds of helpers for this. But one of them is the alignment. The align, which is the act of aligning something. And it takes what direction. In this case, it's not a direction, it's just in the center. And you can initialize that and put that in a variable AL. And let's use that AL to lay out. And it needs the context for putting its operations into. And then it just takes, which is common to all these layout objects in GUI, it just takes an anonymous function closure, where you are expected to draw whatever you want to have centered. So let's see if this works. It does work. So what happens here? How does this layout know how much to move this by? In this case, it needs to move the label half of the window size minus half of the label size. And that's where the layout constraints and dimension system come in. So in some toolkits, you get a layout method. If you have a widget, there's typically a draw method for actually drawing. And there's some layout or size or update method for actually determining the widget size. And that layout or update layout or update method will then have some information from its container saying how much space can you take up. That's how it usually works. In GUI, it's almost the same thing, except that this context contains the constraints at all times in your program. It contains the current constraints for whatever you're drawing. And let's just try to print them out just to demonstrate how that looks like. So in this case, you can see the constraints were printed twice because 2 frames were rendered. And this is pretty much the size of this window. This is the width constraints. Let's just, for demonstration case, let's say, okay, let's print all the fields of this constraints object. You can see here, there are constraints for width and a min and a max, which are the same, which says your widget, whatever is drawn in this window, has to take up the entire space. And the same applies to the height. Okay, but what does this alignment do then? Let's try and print the context constraints inside here. It actually modifies those constraints to say, okay, you can still take up 753 pixels on the width side at least, but you're free to take as less space as you want. And this label only, okay, then I'll take up whatever space is required for me to draw. And that is saved in context dot dimensions. Whoops. So as you can see, this is the constraints that comes to the label, and this is the result of itself drawing and measuring itself. So this is the layout, the label telling whatever is laying itself out that I am 422 pixels wide and 70 pixels tall. And that's what the align object up here, or helper, is using to position whatever is drawn. So in GUI and in immediate mode in general, you're laying out as you are drawing. So this call down here, the layout call, is both drawing and laying out at the same time, which is very convenient because you often figure out what the size of whatever a button or a label or whatever it is as you are drawing, or at least the same kind of code has to be executed anyway. So a more complex layout is the flex, which can lay out things either horizontally or vertically. And you use it by giving it an axis. We'd like the vertical flex because that's more interesting when we have labels. We'll just steal the label down here. And in the flex, you just add children to it. And the way you add children is that I'd like to define a child and say flex.rigid, which means it's not a weighted one. I can show you that in a minute. You give it the context again, and again we have this function closure to describe what is being laid out in this child. So this is the first child. We can define a few more. 2 and 3. And give them some descriptive names, just so you can see that they're different. And finally you say, okay, I'm done. So you say, I want to lay out these 3 children. And again, this is the flex. The flex does this. It simply puts your widgets on a row, which is very useful, very, very common layout operations in any user interface program. Now, if you'd like to combine layouts, of course, then you just do that as you would normally expect. So in this case, we have a flex laying out the labels in a column, but we'd also like to add some spacing. And the standard method for doing that is the layout inset. In this case, let's just take the uniform inset. Give it 8 pixels. And let's just lay out the first label with this. X, like this. So this is creating an object that insets something else with 8 device-independent pixels in each direction, and we're applying this recursively or as a function below the child of this flex. And okay, 8 pixels is not enough. Let's change 50 instead. Like this. So this is actually calling the first child of the flex, and then and that in turn calls the layout method of the inset, which is then laying out this label. So none of these widgets know about each other. So it's simply a dance between the constraints and dimensions all the time. The constraints contain what can you take up in space, and the dimensions return what space did I take up, and then the layout is done in this way. So it's like a function, a stack trace, where you have function calls all the way down to the lowest level of widget, which is then returning all the dimensions up in the stack to the higher levels containers. And this is how you lay out in immediate mode, in general, and also in GU, of course, in particular. I'd like to show you one more layout. In this case, we're going to show one that both has state and is a little bit more interesting than just flex and insets, which is the list. And a list in GU is a scrollable list, actually. So it's a bit like the flex, but it can scroll and it can efficiently render only the widgets that are visible at any current at any given moment. So instead of this flex, we'll have the list, and the list is called, also has a layout. The list functions works like this, that you give it the context and you give it what is the size of your underlying data set. So say you have a list of potential millions of elements. You just tell it, how many elements do I have? I can have 10 million. And then you give it a function. And this time it's not an anonymous function, because it has to tell you which widget does it want want you to lay out. So it gives you an integer that says this is the position in your underlying list, which I don't know anything about, that I'd like to render, that I'd like you to lay out. But other than that it's exactly the same. So let's delete all this. It's like this. And in this case, we'll have the text be defined as, again, GoLab, and give it something that depends on y. Such as this. I think that's about correct. So it's not vertical yet. So we initialize the list with the vertical axis. So here again, we have 1 million elements, and we can scroll freely between them. And the list makes sure that it only calls your func, your inner closure, or whatever you're going to give it, that takes an integer, with exactly, or more or less, exactly the elements that are visible on the screen. So of course, if you scroll a lot in one frame, then it has to draw all the intermediate, all the widgets that are between the old position and the new position. But other than that, more or less, its complexity, its drawing complexity is only dependent on what is visible and not how large your underlying list is. So I think that's it about layout. The final thing, of course, you saw the key handler before, and that was pretty basic. So I'm going to show you how a widget key handler or widget events are structured on top of these input operations that you saw in the beginning of this talk. So let's say you have a button, and a button is stateful, so you have to save it somewhere. We'll just save it here, a widget button. And again, this only contains the actual state of a button, and not anything drawable, or its size, or its appearance, or anything like that. It's just the state, which is it pressed, and if it were clicked, where were the coordinates of the click, and how long ago was it, so it can draw these effects when you click on the button. So you define a button, and you tell the theme. Yeah, we can have. Let's wait with that. It might be useful. You tell the theme, okay, I'd like to draw a button, and you give it the most important thing on a button, which is what is going to be on its label. And with that, you can lay it out. But you also have to give it in the layout what is your button state, and that is saved in the button variable that we had defined up here. So in this case, it's a button that is top aligned, and it's gray. Why is it gray? It's disabled. Why is it disabled? Can you guess it? Huh? It doesn't have what? the events are not handled. Right, exactly. So I don't know if this is a bit too clever, and it should have a disabled property, but I'd like to keep everything as stateless as possible. So in this case, which could be changed if that's not applicable. In this case, the button knows if it has been checked for clicks, and in that case draws itself as either disabled or enabled. So let's take the button and ask it, were you clicked? And in this case, the button should draw itself as enabled and be able to be clicked on. But we'd also like to have something happen, just to see that it actually does something. I'll see if I can resize it again. And if you click me, you can see the click events are handled. So you saw before the input op and where I have to get the queue of the window and ask for its events, and then I got in that case the keyboard events out. The button encapsulates all that. It registers the operations for itself, and it takes all the pointer events and pattern matches them to see whether it's a full click. And all that is encapsulated in just this one call clicked. And you can have an if you'd like only one click per frame, or you can have a for if you're counting something and you'd like to accept multiple clicks on this button. And again, I think it's important to emphasize that this is happening as your program wants it to. In this case, I have a very small program, so of course it's happening while I'm drawing. But in theory, you can have this check for button click at a completely other section of your program if you'd like. So you can have something that handles states and events, and you can have something that handled that did the actual drawing and setup of your widgets. And I think we are about to run out of time. So I'm going to stop here with showing you what is possible for a larger Gio program. I've written at least 2 programs for which are interesting for us today. The first one is, did anyone go to my talk 2 years ago about Go Mobile? Anyone? No? 2 years ago? You did. Do you remember what I showed? No. It was a Bitcoin. It was a Go Mobile application that showed a Bitcoin wallet. That was just one of the demos. So it's very, very simple. It connects to a local. It's very large because the resolution is so low. It connects to an existing Bitcoin node that runs in the background here, localhost, and it watches this address, a Bitcoin address, for incoming transactions. And as you can see, I have someone very special in the audience that actually sends Bitcoin, in this case testnet Bitcoins, so that this is actually a live transaction that happened a few seconds ago, that is then processed by this background node and then received by this application here, written in pure Gio. So 2 years ago I had this running in an Android phone, and that's it. And it was written, some of it was written in Java, and some of it was written in Go, and so on. In this case, there's a tool for simply taking this application and targeting it for Android. And I also have an emulator running. I can't show the device because it's too small for you to see, but it works pretty much the same way. So, and this command then outputs an APK ready for you to install on a phone or emulator. Like this. There you go. It should appear down here. So again, this is the exact same code you saw, or at least the same type of code that you saw written here. There's no native code in it. There's no Java. There's no nothing. There's no knowledge of being on Android. And it could build in some knowledge because you have to handle things like this bottom bar overlapping, but that is something that you get from the events that you can compensate for. But other than that, the application is exactly the same on Android as it is on the desktops and in the browser. And I'm also going to show, just so you can see that it's actually possible, the build for iPhone. In this case, I have to give it an app directory because it's the output file is different between running on an actual device and the emulator, which is what I have. Over here. It's just a different command, of course. It's installed on a booted emulator. This one. Let's see if I can on this screen still. Okay, this is the app that was produced and installed, and you can't see the button because the phone is too large for the screen. I think that is what you're going to see on the screen. Okay, but you get the idea. The same code runs on multiple devices, different devices, runs on Windows and runs on Linux and so on. And of course, the thing I've shown you before, if you've seen any of my other talks, I'm going to show it on the Android phone because it actually takes only the available space of the screen, is scatter, which is very, very shortly, it's a end-to-end encrypted messaging, which instead of phone numbers and a central service, use your own email address and your own email SMTP and IMAP. So if anyone is interested in that, that's not particular GUI-like, but it's written in GUI. So if anyone is interested in that, that's also a separate project that I'm working on. And it can actually write messages that you will then receive on the other end, which could either run on the desktop, on an iPhone, and so on. And finally, I'd like to point out that if you'd like more detail in this, and perhaps even be taught how to write GUI programs yourself, then I'm going to have a workshop tomorrow, which is doing pretty much the same thing, but showing you, with you, programming a GUI app from the bottom up so that you can know both how to run it and how to use it and how to use all the other aspects of the GUI library that I haven't shown you yet. So thank you very much. Do you have any questions? Mm-hmm.
You get a context for the window. Okay, immediate mode is very convenient when you are doing, I don't know, 3D graphics and you have context. So can you access that in GUI?
No.
Okay.
And the reason, that's a short answer, but the long answer is the same answer as fine Andrew gave you. The problem is that GUI is hardware accelerated, so it uses the GPU to draw everything. So in fact, even the letters are not textures. It's not just a flat image. It actually draws all the curves in real time because it can use the GPU. But it doesn't know whether it will run on Windows, where Direct 3D is the prevalent API, or in Vulkan, on Android and Linux, or in Metal with macOS and iOS. So it's difficult, and I think you got pretty much the same answer. It's difficult to expose an interface. I'd really like to do it, and this is one of the things I'd like to do in GUI 1.0, somehow exposing the programmability of the GPU to you as a user. But it's a very, very difficult problem. So the short answer is no, and yeah.
It looked like with each frame event you had to redraw every object that appeared in the window.
Yeah.
Is that correct? So
yes.
That's not going to get too slow in a complicated window?
I hope not. There are two things. Of course, the events are batched. So if you have a very, very high resolution cursor or finger or a touch screen, then all those events that has appeared while you draw the previous frames are batched up and reported in one big batch to your next frame. And the second part is that most of your program is spent adjusting and setting up coordinates and issuing drawing commands. But the drawing commands themselves are not that data heavy. So a paint is just 4 floats or something like that, and a color is just 4 bytes for the color and so on. And an image, if you want to draw a profile image, for example, then you will have that image data, of course, given to GUI. But once it's seen that image, it will cache that as a texture on the GPU. So you will only, from then on, draw it with just a handle, which is a pointer, and that's it. So there's actually remarkably little data involved, even in complex application as this one, more complex at least. And well, the GPU does most of the work. That's the other part of the the response. So you do the definition of the frame, but then that is passed off to a Go routine that does some pre-processing, and then the GPU does all the heavy lifting. And of course, immediate mode comes from games. This style of writing user interfaces is inspired by the game mode, the way you do it on games, where you have constantly changing viewport. As soon as you move around in a first-person shooter, your viewport, the entire screen changes. All the pixels are changed. And that's why the UI was a natural thing to do the UI in the same way. And I suppose that if games can do it, then I hope that we can do it as well. But that is one of the thing that is an experiment with GUI, I would say. Can this scale up to large applications? I honestly don't know yet, but until now I haven't run into any performance problems.
So under which circumstances is the frame event generated, and what do you have to do if you want to initiate a redraw from the program?
Good question, good question. I'll just show it very, very quickly. So if you are a widget and wants to animate, for example, I don't know if it still runs the button. For example, this animation, you'd like to redraw as fast as possible. As soon as you see the click, you want to redraw. You can issue invalidate op, which is just an empty operation, and add that to the. And if the system sees an invalidate op anytime, at any point, then it knows that it has to redraw as fast as the display can handle. And this invalidate op can take a time which you want to do it. So if you have a blinking cursor, for example, you can say, I'd like to have invalidated, which is give me a new frame in half a second or something like that. And finally, if you have something external, let's say a network event or something that is external to your Go routine, you can call window.invalidate directly, which simply asks it for redrawing as fast as possible. And again, and then the final thing is the automatic frames, which comes when you resize your window, of course, and the window needs to be redrawn, or if input comes in that actually hits some of your handlers. So if you don't have any handlers that handles the key or the point events, then nothing happens. But as soon as you have a handler that needs to get this event, then a frame event is generated. Anything else? No? So thank you very much. I hope to see you tomorrow. And one final thing, if you'd like to, I will show you tomorrow in the workshop. I'll show you how to program this example app from the button up. But if you'd like to do it yourself on your own laptops, you might have to install a few things. You can go to GUI.org to see what the installations. I'll just see if I can find it here. So we go here. These are all the links for it. You have to go to GUI.org and then look for installation. And for your platform, if you have Linux, you need Wayland. If you have macOS, you need Xcode. And for Windows, you actually only need a few DLLs. If you'd like to run it yourself, then please see if you can run one of the example programs in there. If you can run the example program, then you can run whatever we're going to do tomorrow. If you can't do that or want help with it, I will be here at the entire conference, and especially in particular 1 hour before the workshop tomorrow to help you with any installation problems you have, because I won't have time to help you during the workshop because I only have about 2 hours. So that's about it. And especially if you want to work on mobiles, please make sure that you have either Xcode or the Android SDK and NDK and all that at least installed, because they're big and they take a long time to download and install. So thank you.